بسم الله الرحمن الرحيم. الحقيقة أهلا بكم أحبتي في درس جديد وممتع وشيق إن شاء الله في لشرح منحني اجهاد الانفعال للمواد المطيلية وكذلك المواد القصيفة ليست القصيفة والمواد المطيلية والنصف المطيلية والمواد البوليمرية وكذلك المواد المتراكبة لمختلف أنواع العينات القياسية المتمثلة بالعينات المستديرة والعينات المطولية أو العينات المستوية ليست مستوية وإنما العينات فقط الدوارة لاختبار الشد وإدخالها إلى اختبار الشد وتقديمها باختبار الشد للحصول على نتائج قياسية عالمية لاختبار الشد بالنسبة للمواد المطولية ورسم منحني اجهاد الانفعال لتبيان تصرف الاجهاد والانفعال خلال اختبار الشد. So then we've got the most gracious, most merciful here, the all living, the self-sustained. Today and once again here again and today brand new lecture here just to study and visualize and attempt to visualize the curve of strain behavior for the ductile material or semi-ductile material as well as the materials are actually described to be termed to be a composite materials or even polymer materials here by using a special standardized spacements said to be very standardized global spacemen according to the SI systems or even standardized global spacemen by the ASTM system standardization and tend to be in the formology of in the formology or tend to be formalized or even fabricated in the sort of rounded spacemen or even flat spacemen, as you can see right in front of you. But not flat spacemen are not going to be used in the test we're actually trying to conduct right here, and particularly in this time and hour, or even we'll try to visualize as well. So today we have the lecture 7.2, the stress-strain curve. The consequences of the stress-strain curve or this tensile stress is or tensile test is placed or plotted in the stress-strain curve, which gives or even offers the relevancy or the relationship between the relevancy or the relationships. هنا سوف نعطي لكل كلمة مرادفاتها في اللغة لكي تعرفون المرادفات بإذن الله تعالى، تعرفون المرادفات للكلام في اللغة الإنجليزية والعربية. The relevancy or the relationships between the stress and strain representing the stress or the stress-strain curves, as you can see right here for you, representing for as a variety of materials that can be plotted by signing up for the testing results or consequences here, or the testing outcome at which the corresponding formology or the corresponding formation of certain loads will be gauged with. يعني التي يقاسها فيها التشكل المناظر لأحمال معينة. And the stresses will be even represented or even plotted with the vertical coordinate axis, as well as the strain will be plotted or even will be represented or even will be visualized or even will be plotted or even graphed to the horizontal coordinate axis. And the curve is actually different according to the type of materials used or the type of substances that are actually used. So the metals are pretty much different in their behavior affected by the tensile load or the axial tensile load according to the nature or the physicality of the materials used, such as as you can see, as you can see right in front of you in the first article here of the topic we're about to visualize right now. As you can see right in front of you, the ductile materials are the materials which with a stress-strain curve, or the materials possess stress-strain curves illustrated in figure 4.2a by the existence or even by the displaying or exhibition of elastic region is said to be a straight line indicating a direct proportionality between stress and strain at the same time in any plastic region, as well as a plastic region. An interstitial region lies in between the plastic region as well as the elastic region, called or denoted or termed as to be the yield region, as well as it characterizes or even the materials are characterized or even featurized by a very substantial deformation just before fracture happens or just before fracture, as well as they featurize the formation of necking as a result for this the soft steel. So as a result of four sides here for the entire materials, which is going to have to pick you a solid size here, which is going to have to pick you a master size for the materials, for the ductile materials that are actually used to behave so, such as used to behave so as indication or as significant for this soft steel to be mentioned. As you can see, well, as I indicated, as we stipulated for, God willing, of course, God willing, surely the glorified and exalt, to the semi-ductile materials or the semi-ductile minerals or even semi-ductile metals, which are the metals with a stress-strain curve illustrated in figure 4.2b, featurized with the exhibition of the elastic region as well as the plastic region, but without yield region interstitially or without yield region in between, as well as it happens to be, it happens that as well as a moderate deformation happens to be or happens to take place, as well as characterized with the formation of nickings less than the technical materials, such as the high resistive steel or high resistance steel. Brittle materials or brittle metals. Third article. Third article is indicating or signify a brittle metals, which are the metals which have no yield region, as you can see, which have yield region pretty much, and no direct proportionality between stress and strain. So the curve illustrated in figure 4.2d since the beginning is to be an oblique line or even a slope, not a straight line, other than to be a straight line, as you can see in front of you, but not straight line. straight line. And the metals will undergo, or even the metals will undergo, or even the metal were experiencing a very small deformations as compared to the further materials used with no nicking, as you can see, such as the pig iron or even cast iron. High plasticity or high elasticity materials are the article 4. High plasticity materials, the high plasticity material are very much exhibiting strain or exhibiting elastic strains of 100% ratio, such as elastomer and plastic materials, as illustrated or as it's clarified in the figure, or as disambiguated or as clarified or as visualized in the figure 4.2g. As you can see, with this is a strain curve for the tactile materials. As you can see, we're with this straight line commencing from the beginning, where the point is actually commencing between the stress and strain. So at the stress, any linear increment in the strain, as you can see, it will be accompanied by a linear increment in the strain in the same level. So strain is actually plotted to the horizontal axis or horizontal coordinate axis, as well as the strain, just like we stipulate, is plotted to the vertical coordinate axis of y, and the strain and the horizontal coordinate axis of x. So any linear increment in stress, or any linear augmentation, or even a linear oscillation in stress, will be accompanied by a corresponding linear increment in the strain, as you can see right in front of you, in the form of a straight line or a form of a slope commencing from the point of origination of the both stress and strain. Origination, or the stress and strain extension right into a certain point called the point of yield, or point of yielding, or the yield point, the upper yield point, as well as the lower yield point. At the lower yield point, the material will commence behaving like a plastic materials. From the lower, as you can see, from the lower yield point or the upper yield point here, the material will begin, or even will commence, will behave plastically till the material reaches the fracture point, as you can see right for you here. The ultimate tensile stress will be measured right along or right at the curve commencing from the upper yield point into the fracture strength, or to the point that indicates or even signify the fracture point occurrence, as you can see right for you. The UTS, the ultimate tensile stress of the material used, the ductile materials such as the soft here, or any ductile materials that actually used other than the soft here, the tensile stress will be lying right here at the curve, in the curve right here at the top peak of the curve, as you can see right funny here. And with respect, or by the way, for the as you can see right in front of as you can see right in front of you, this is the stress strain representation, or the stress strain visualization for the semi-ductile materials. As you can see right in front of this, approved stress is represented in the type 2 of the semi-ductile materials, or type 2 of materials used to be conducted, or the materials used to be tensilely tested. As you can see right in front of you, the approved stress is extending right parallel or in parallel to the straight line of direct proportionality between the stress and strains, called the limit of Young modulus, or even called the limit of Young modulus, or the limit of the elastic moduli. The elastic moduli, many of her curriculum handout يعني الكثير من المناهج الدراسية تسمي معامل يونغ بمعامل المفعولية أو معامل المرونة. Many of curriculum handouts will denote to the Young modulus as the moduli of elasticity. Moduli or even modulus, both of them are the same correct determination, or the same correct denotation for the same component of the stress strain curve. as you can see right in front of you, this is the endurance limit. The endurance limit lies between at the point of intersection. At the point of intersection between the proof stress parallel optic line and the straight line of proportionality between stress and strain is called the line of the Young moduli. At the intersection point is measured between the proof stress extending right from a 2 or an 0.002, as you can see right in front of you, till a certain point here at the stress strain graph. The point will be considered or will be taken as the endurance strain. So the ultimate tensile stress is also presented or even also introduced, also exhibited or even also displayed or also emerge. يعني أقسام مقاومة موجودة كذلك في المعادن النصف نطيلية. Here as you can see in front of you, here's the figure 4.2, illustrate the curves of the stress strain for variety of materials. Here A is the ductile materials, and then B the semi-ductile materials, and the G is the, as you can see, or G in Arabic here, is going to be like the high elastic materials such as the elastomer, as well as the, and as you can see in front of you, as illustrated or as visualized, or as clarified right here in front of you, as you can see right in front of you, in the D section of the figure 4.2 illustration. As you can see right in front of you, here's this gene, which is going to tell you about the gene here. The gene is pretty much heteromorphic. يعني homomorphic يعني معتدل الشكل او متجانس الشكل كما ترون امامكم. homomorphic او homomorphic متجانس الشكل. So the relevancy يعني العلاقة the relevancy between the stress and strain at the same time is pretty much homomorphic, and the curve drawn on it display the homomorphicity. Displays the relevancy displays the homomorphicity between the stress and strain at the same time, and the extended curve from the point of origination consider the point of the intersection between the stress and strain coordinate axis, since the stress is actually plotted to the y vertical coordinate axis and the strain is plotted to the horizontal x coordinate axis. This is the curve extending from the point of origination, as you can see for you, till a certain point in the plan or in the quadrant. Certain point in the quadrant يعني نقطة معينة في الربع، لأن هو الأرباع هي في المستويات الإحداثية. الأرباع هي عبارة عن مستويات إحداثية because just the quadrants are said to be a very much coordination planning or even coordinative planning or even a planner of coordination, as you can see word يعني أقسام أو مستويات توجيه أو مستويات إحداثية. This is very much illustration for the strain curves. For further materials or for further intels يعني لمعلومات أخرى عن الخواص الميكانيكية للمعادن كما ترون أمامكم هنا. 8.2 is illustrating the mechanical properties of metals in tensile test or even tensile test. We can only conclude from the tensile test the mechanical properties or mechanical features of the following metals. The following mechanical features can be extracted, or the following mechanical features can be even obtained from the tensile test for the following metals. يعني نستنتج من اختبار الشد الخصائص الميكانيكية المعادن التالية. First, as you can see, what is the proportionality limit, and then the elastic limit, and the yield stress, and the proof stress, and the resistance or the strength, and the fracture stress, and the ductility, and the elongation or the extension, and its resilience, and the toughness, as well as the hysteresis. The hysteresis is التخلفية in Arabic. The figure 4.2 illustrates the stress curve very much optimal for ductile materials, which highlighting the mechanical properties indicated to, and explains also the formology of this spaceman, or even the form or the shape of the spacemans at different intervals or in different points of the tensile curve. Here, as you can see right in front of you, as you can see right in front of you, the stress strain is illustrated just like we stood like before, illustrated to the vertical coordinate axis y, which represents y, as well as the point of origin, which is the point of intersection between the both coordinate axes, both orthogonal and the both perpendicular and the both normal to each other stress strain curve, or the stress strain orthogonal axis of coordination. As you can see right in front of you here, at the proportionality limit or at the proportionality boundaries or frontiers يعني عند حدود المرونة. Here, as you can see in front of you, the materials or even the bar, as you can see, where the bar used or even the materials placement is actually used capable of restoring or recovering the entire plastic mechanical energy or elastic mechanical energy possessing from the tensile test conduction, as you can see right for you, capable of restoring the entire energy as well as restoring the entire original size and shape or retaining the original size and shapes after the load. Here, as you can see right for you here, after the upper yield point or after yield point or post yield point region or post yield point face يعني حالة, as you can see right in front of you, the material specimen will begin to undergo an elongation or even begin to experience very much an elongation here. Elongation will lead in the subsequent point, يعني في النقطة اللاحقة, will lead in the subsequent point, as you can see right in front of you, to the stress strain curve after the UTS, which is said to be or termed to be the ultimate tensile stress. Here the neck happens to the specimen till the specimen reach the fracture point or the fracture place, as with the material will not be able to restore or even not be able to recover the original sizes and shapes after the load, as you can see right here in front of you. Here, figure 50.2, the stress strain curve for a very relatively ductile materials is illustrating the shape and the form of the specimen at different points of the tensile curve or at different points of tensile behavior. يعني عندي فترات مختلفة من تصرف إجهاد الشد أو تصرف الشد, اختبار الشد. As you can see in front of you, the figure 6.2 is the stress strain curve for a relatively ductile materials illustrating the variety of regions presents. يعني مبين المناطق المختلفة المتواجدة. As you can see right in front of you, from the point of originations at which the stress strain is launching from, or the stress strain curve is as well as the stress strain curve is launching from, and the stress strain axis, orthogonal axis, or even the normal or perpendicular axis to each other are launching from. As you can see right in front of you, this is the proportionality limit launch from the point till a certain point called the point of yield or the upper yield point. As you can see in front of you, the upper yield point is the B, as illustrated in the figure, and the elastic region lies just between or lies interstitially, يعني بينيا, تقع بينيا منطقة المرونة وحد المرونة يقع بينيا بين النقطة نقطة الأصل O وإلى حد معين في الانفعال. So the proportionality limit is actually lying interstitially between the point O and certain limit here at certain point in this stress strain curve called the upper yield point, as well as a certain limit and the mapping of the point B, as you can see right in front of you, right to the strain coordinate axis, which is said X by the way, here by the way, just by any chance called BX or denoted BX, denoted as X, as you can see right in front of you. This point is actually called the point of proportionality, or the point at which the proportionality between the stress and strain fulfilled, or the point at which the proportionality between stress and strain is actually accomplished, as you can see right in front of you. After the point B, the material will be undergoing or will be able to experiencing a very much different point of or even different behaviors of material different behavior of the material, and as you can see right in front of you, of the material, different manners or different points of material manner affected by the tensile test, as you can see right in front of you here. The material will experiencing a plastic region right from the point P right into the point of ultimate tensile stress, which should be called the UTS, as you can see right in front of you here. From the B to D, this material will undergo a plastic region just because the materials will no longer be able to recover their original size and shape after the load or after the removal of the edge or after the removal of the load, as you can see right in front of you here. Then we're reaching the ultimate tensile stress. Toll's ultimate tensile stress is actually a point representing the boundaries, or representing the separated boundaries or the separated regions between the plastic elastic region and the plastic region. Plastic region will commence after metal exceeding or after metal overcoming or even after metal uptaking or even overtaking or even surpassing the point of UTS, which is said to be here D, as you can see right here in this stress strain curve illustrated right for you. So after the point D, after UTS, just like we said, after exceeding the point UTS of D here, as illustrated in the figure, the point will be, the material will experiencing a very plastic region at which the material will no longer be able to recover their original size and shapes after the load till they reach a fracture point, at which the point or at which the spaceman will be able to fracture and deteriorate, or will be fractured and will be fractured and cracked under the effect of or affected by the load, or affected by the tensile stress increment, or tensile stress augmentation, or tensile stress oscillation, as you can see right here. The mapping of point E is the fracture. The mapping of point E to the vertical axis of the stress representation, or the stress plotting, is called the fracture point, at which the materials are fractured and affected by, or at which the material is fractured, affected by the stress relieving, or after affected by the stress oscillation, or the stress augmentation, as you can see right in here. The figure 6.2 is the stress curve for relatively ductile materials, illustrating the variety or the various regions, or the various points, or the various dots, or the various spots to the stress strain curve. As you can see right in front of here, the protection mechanics, the article 1.8.2, the mechanical features of metals in the elastic region. The elasticity is the ability of material to restore, or even to recover, or even to retain the original sizes and shapes, and having a permanent deformation, or a permanent formation after the load, as you can see right in front of here, after a vector load. The proportionality limit. 1. The proportionality limit, the article 1 here. The illustration and visualizing for proportionality limit is actually fulfilled right now, and as well as the Hooke's law. From the point O to point A, the stress will be proportional with the strain linearizely يعني خطيا يوجد إلى خط خطية, a straight line between the stress and strain origination from point O, which is the point of origination between the both perpendicular and the normal and the orthogonal coordinate axis of stress and strain plotting to each other, and the strain in the same time. This region, which is the Hooke's law, is applicable. In this region, the Hooke's law is applicable due to the scientist Robert Hooke, or due to the physician Robert Hooke. يعني نسبة العالم روبرت هوك, which we can only find the relationship between the relevancy, or at which we can only find the relationships, or at which we find the relationship or the relevancy between stress and strain as follows: E equal to sigma, as you can see, consequently, or even subsequently illustrated in the figure, or even illustrated in the relevancy between the stress and strain at the same time, related or even correlated by the Young modulus 16.2. That's correlated by Young modulus, but it was seems to be like the stress, or even the relevancy between stress and strain is actually represented, or even yoked by the يعني مربوطة. Yoked is actually by the Young modulus, or the moduli of elasticity. So the stress is the notation here for the Latin prefix of sigma, indicating that the stress is actually measured by Pascal, or even indicating that the stress is actually possessed, or even stress is conducted, or even infiltrating through the material, as you can see right for you, measured by the Pascal on the Newton meter squared, or the Newton meter squared. And this stress is actually, as you can see right for you, is represented by the E letter, this strain, as well as the engineering strain, just like we stipulated before, represented or even denoted by the prefix of epsilon. Epsilon is the prefix of Latin alphabeticality, or the Latin alphabet here, indicating that the strain in English, that strain in English is actually pretty much a nominal strain, or even an engineering strain here. As well as the epsilon is used actually for a relative permittivity in the electricity, or in the static electricity. يعني كذلك الأبسلون ترمز لي ترمز لي السماحية الفراغية، أو السماحية النسبية ليست فراغية، السماحية النسبية relative permittivity في الكهربائية الساكنة. E, the elastic moduli, are the Young moduli as indicated, measured by Pascal or Newton meter squared. The proportionality limit. The proportionality limit is in point A, where the maximum stress value is lying at, or the maximum stress value is, where the maximum stress is gauged at. يعني بحيث يكون أقصى قيمة الإجهاد. at which the relevancy between the stress and strain is linearized and denoted by this sigma p. The sigma p is the sigma at the proportionality limit, or the sigma of proportionality limit. We can only calculate the modulo of elasticity, or even the Young modulus, by using the coordinates of any point mapped to the straight line, any point mapped from the straight line to the any of the coordinate perpendicular axis, as we indicated, such as the stress and strain, especially the direct proportionality limit point. E equal to sigma p, EP, as you can see for here. Young modulus is actually considered very much a gauge for the stiffness of material, or any material stiffness, in the limits of the stiffness elasticity, which is the resistance of material for formations affected by loads, or which is the resistance or even the strength of materials for any elongations affected by the tensile test. More Young modulus value you get, or more strain value, more elastic strain for any corresponding elastic stress you will get. Consequently, more stiff material, as illustrated in figure 7.2, you will get more stiff material. Consequently more stiff material you will get as illustrated in figure 7.2. يعني بالتالي كلما زادت صلابة المادة، يعني كلما زادت صلابة المادة زاد معامل يونغ لها. برجر تم بحمد الله.